Good morning, everyone. Welcome to the webinar. My name is Thiagu Palaniappan. Let me welcome you to this webinar on behalf of TriStar and Ansys, our new partner. So we are really excited about our recent partnership with Ansys to resell their new Ansys AIM product. As you may have attended many of our Thursday webinar series, today is our first one on the Ansys AIM product. The idea and the goal of this is to give you an introduction to AIM. So from an agenda standpoint, I want to really quickly go through a few slides on what exactly is Ansys AIM, what are its capabilities, and I want to spend most of the time during the presentation, the next 30-40 minutes or so, on the demo so that you can see the product as to how easy it is to use, at the same time powerful, with several capabilities that I'll try and show as much as I can in the next 30-40 minutes here. All attendees are currently muted, so it's at the bottom. If you're using GoToMeeting or GoToWebinar for the first time, you should see a chat window. If you could please start typing in your questions there. I'll try my best and answer it towards the end. Maybe the last 10-15 minutes, we'll open up the floor for the Q&A. But meanwhile, you can start typing in your questions in the chat session. So really, many of you may have heard of, I'm sure all of you know about the industry leader in CAE, which is Ansys. Been there for several years. They have several flagship products. Recently, they've come out with this new Ansys AIM product, which is essentially an environment, an immersive environment, wherein it's an integrated solution, I would say, for 3D simulation, right, with multiphysics capabilities, obviously. And it also is built on, ground up from the Ansys technology that's proven in the industry already, right? So, but the goal is it's really easy to use, one single environment for designers, engineers, and that don't have a lot of analysis experience. You're still able to use it since they have a lot of automated workflows, tasks, process templates, which I will demonstrate in a little bit when I do the demonstration. So really, all the way from geometry creation, preparation, defeaturing, what have you, that you normally do in an analysis, right, in any analysis tool, and all the way to meshing and then doing the physics setup, whether it's going to be fluid flow simulation or just a straightforward static analysis or stress analysis or electric conduction or maybe multiphysics where you do have a fluid structure interaction situation. So all these are done in one single environment, including the ability to create fluid volumes, edit geometry, what have you, right? So, Ansys AIM is really, you can think of as an environment, very easy to use, but still has the breadth and the depth of capabilities that you have seen, or the power that you have seen, or that we all know about Ansys flagship products. Now, let me just go over quickly some of the key capabilities that you have in Ansys. One is the integrated geometry modeling. So whether it's a structural analysis or whether it's heat transfer or fluid flow, as you know, there's always some amount of time we spend on defeaturing the geometry, maybe cutting the model in half, right? Or maybe in a fluid flow situation, you want to have the fluid volume, right? For all these situations, right, instead of using different systems, Ansys AIM has a single environment where you are able to switch between the space claim engine-based editing environment, right, that you see on the slide there, and then you can get back to your simulation environment really quickly, including the ability to add checkpoints, do design optimization. Now, as for what type of CAD files you can import and what type of integration you have, here's a quick snapshot of the various CAD files that you can import directly into AIM. Other than the typical neutral files like step or IGES, you can most of the major CAD systems are supported in Ansys AIM. I also have a screenshot there of Creo Parametric. So if you were to use Creo Parametric, you are able to have an interface to Ansys, so wherein essentially you are working on your geometry or modifying your geometry in Creo Parametric, and that can be updated or synced in Ansys AIM, right? And if you're not using, if you're using any other file type, there are, the space claim is something that's the engine, the modeling engine or the editing engine within Ansys AIM that allows you to edit geometry and allows you to expose parameters so you can make or run what-if scenarios, which is very important from an engineer or a designer standpoint, right? Other than just the how much questions, the what-if scenarios, that's very important, right? It also has robust meshing capabilities. So I'm sure you know, all of you, if any of you have used Ansys in the past, you know about the power of Ansys, wherein it has you know, specific meshing tools like, is it a tetrahedral mesh or a polyhedral mesh, depending on the physics. So all that is included in Ansys AIM. It also has fluid flow simulation, which you know, most of the time you might want to do fluid as well as structural analysis together, but steady-state fluid flow, which I'll demonstrate these when I in a few examples. For example, you might just want to evaluate the pressure drop in a pipe, right? You want to calculate the lift and the drag. So all those capabilities that you would see in a typical computational fluid dynamics tool. So there is a fluid template within Ansys AIM that has automated tasks even for a new user. You don't have to be an expert user. You could be a new user, and you can also have your analysis group customize those if required, if they want to deploy such templates or best practice on such analysis throughout the company. And as always, structural analyses is also supported. Some of you may be doing mainly structural analysis. All you want to do is a deformation analysis, right? You're just looking to check the maximum stress, the maximum deflection on a simple part or a complex assembly with interface definitions. Or maybe you want to do a fatigue analysis, stress-based or strain-life-based fatigue analysis. So that's also supported in Ansys AIM, including modal analysis, right? For example, many times you just want to know the natural frequency and the mode shapes of the product you're going to design. That might go, you might be designing a simple bracket or a control module, but that's going to fit on an engine, and the engine has a frequency, and you want to make sure that it doesn't match that, so you can do modal analysis and static analysis on the structural side. And also thermal, you're able to model conduction, convection, radiation thermal modeling with Ansys AIM, with the ability to do multiphysics coupling. So with the change in temperature, I would like to know the thermal expansion, obviously, and the thermal stresses due to that, right? So that's also supported in Ansys AIM. And then the fluid structure interaction. You can see the example of the solar panel right there, where obviously I need to do a fluid flow analysis. At the same time, I want to really couple the forces and the pressure that I get out of my fluid flow into a structural analysis and see the structural performance of the entire product or the assembly, right? So in most designs these days, I'm sure you've seen, it's not just one physics where you're just checking for structural or thermal or fluid flow. Most of the time, it's a combination of all of these, right? Even if you were to do a simple thermal analysis, you're always, you know, what kind of convection heat transfer coefficient are you going to give, right? Are you simply going to come up with some numbers, right? Depending on if it's free or forced cooling. So for all those, I think the most accurate way to simulate all the multiple physics that's happening around your products is best done using this type of a multiphysics coupling, which I'll show you. There are several templates that's built in to AIM, and you can also customize on top of that. There's also DC electric performance. You know, so you could simulate DC electric, for example, in that fuse example there. You are able to assign a current, a voltage. You can check the current density, the temperature, And here there's another example where you obviously want to know, due to the change in temperature, what about my thermals, what are my stresses due to thermal expansion, right? So that's another example of where you are creating a thermal electric stress combination, or and then running the analysis in one single environment. Regardless of which type of physics that you're going to analyze based on your product designs, you do have full capabilities with respect to the post-processing or visualization of results, right? Whether it's a structural or thermal or heat transfer or fluid flow. And also from a processing standpoint, Ansys is really known for, they have a lot of tools like HPC, high performance computing, that helps you really work on very, very complex assemblies and your complex products, and still able to rapidly create or run the analysis in short time. And now with an Ansys AIM also, you have the same power because it's based on the same solver technology, right? Now, one important thing during my industry days, I used to be an analyst as well as a design engineer in the last 15, 20 years of my industry career. I've seen that, when your boss is asking you what is the maximum stress, right? What is the maximum deflection? What is the pressure drop? Things like that. That's all great, but then after the how much questions, what about the what if scenarios, right? That's also very important in my opinion, because how are you going to improve it, right? How are you going to improve your product design? Are you going to just do trial and error, go back, change the design, just do a guesstimate on certain dimensions based on your experience? And then, or most of the time, I'm guilty of it, we over-design, right? Sometimes we just over-design it and then rerun the analysis, check it. So you don't have to do that, since Ansys has an embedded optimization exploration functionality, wherein you are able to use or create checkpoints, and these checkpoints allow you to select inputs as well as outputs from your analysis model, like the design inputs, right? It could be from a CAD software that you're currently running that you can expose within Ansys AIM, or it could need not be, it could just be a neutral file, and still you could use a space claim design engine, right? That's working behind the scenes of Ansys AIM that allows you to parameterize that design and then try to run what-if scenarios, right? So this is one of the most important things in my view. When you're a designer or an engineer, you don't want to go back, change the design, rerun the analysis. You want the analysis tool itself to help you with those type of what-if scenarios, right? So that said, let me open up Ansys AIM. So my plan is to show you both single physics as well as multi-physics examples within the time we have here real quick. First off, you can see the interface, right? This is Ansys 17.0, the latest release. And as you can see, I have a study tab. The first thing you'd really notice is before even opening any file or any CAD geometry, the first step you are presented with is really to select a predefined template. So whether it's structural, fluid flow, thermal, electric conduction, or multi-physics like fluid structure and traction, right? You can also create user-defined ones, like I mentioned earlier, right? That can be customized. It's fully customizable. So let's say I want to do a very basic structural analysis first. I'm a new user, right? And I do have a workflow here at the bottom. As you can see, the workflow tab is empty right now, but I'm going to select a structural template. As I select a structural template, I'm presented with some options here where I want to define new geometry using the space claim engine, or import existing geometry, or connect to an active CAD session. I'll show you these multiple scenarios with different examples. But for now, let's say I happen to have that geometry in a different file format. I would like to import that. Now, if it's an assembly, it's pretty nice that it can automatically detect contact and interfaces, which is very important and critical in an assembly analysis, right? So let me go create. I'm just going to also allow editing. so that once I run the how much question, once AIM answers me the maximum stress, maximum deflection, etc., I would also like to know if I change the radius of my fillet, or maybe I change the whole location, things like that, how is it going to affect my stress? So I'm going to have the template allow me to edit geometry, right? So I'm going to define the template here, right? I'm just selecting a few options and creating a simulation process. Now the software prompts me for a type of file that I can import. And here's just a quick, you can see, let me just zoom in here. You can see the different file types we support, right? Including Creo parametric, Creo elements, direct modeling, SolidWorks, Solid Edge, right, NX, what have you, Step, IGES, etc., right, including space claim. So here's a space claim. Let me just open up a bracket, a space claim part here. And what it's doing right now is, as it's bringing in that geometry into AIM, it's also loading a workflow for me at the bottom, so you could see that, right? So you're a new user, let's say, so really the idea is to get you up to speed in AIM really quickly. The learning curve compared to the traditional FEA tools that you may have seen, it's really, really very less here. As you can see, I got the geometry, and since I used a structural template, it says the geometry is fine. I got the geometry. However, I do have some lightning bolts here where the mesh is out of date. I need to create the mesh, right? And the physics, right? I need to set up the physics, obviously, and then go to the results. So pretty straightforward if you think about it, right? Pre-processing, run the analysis, post-process. Very high level right there, right? And so all I really have to do is I just have to follow these tasks in my workflow, right? I go to my mesh, right? And when I go to my mesh, you see how my tabs change, right? And just like you're used to doing in any CAD tool, right? Even in a simulation tool like AIM, you are able to use right mouse click. So right now, if I don't know what to do, it's telling me right there you can generate the mesh. Pretty straightforward. So the blue, I just follow the blue icons right there, or the commands in blue, and it walks me through it. So it's really like a guided process workflow. And so let's say I generate the mesh real quick. And obviously, you have all those mesh controls that you can specify if required. You have options here. But right now, and you can also control a simple slider here where I can control the resolution. In the interest of time here, I'll just leave it to a low resolution here. So I got the mesh, and you see how that out of date icon on that is gone. Now, obviously, the next step is to go to the physics, right? I go to the physics, and what I get in that physics is obviously material assignments, interface definitions, if it was an assembly, right? Solver options, etc., including monitors. But right now, can I solve it though, right? I don't have the option to solve. It's pointing me, it's helping me, as you can see here, right? It's really helping me in my right mouse click, telling that, hey, you got to add boundary condition, right? Obviously, how is it? It's this particular part, assuming that maybe, let's assume that this is going to have, you're trying to test it for a certain load, right? That's going to, it's, let's say, it's constrained here, and that would be my boundary condition, and I'm looking to apply a load, right? Let's say in the Z direction, something like that, to the holes there, right? It's really a bracket used for aircraft engine components, right? To list them, obviously. So we're just trying to analyze it for worst case condition or simple stress analysis here, right? So my first thing I'm obviously going to do is I'm going to go and add boundary condition, and I'm going to add supports to it. So I'm going to say, okay, let's just collect a few surfaces here. And I'm adding those surfaces, and I've added a boundary condition, a support there, right? So again, if I go to my boundary condition, right? So if I go to my boundary condition, that's the boundary condition I have, right? It kind of tells me how I fixed it. That's a support now. I can also add force moments, pressure, load, etc. Right in here. Now, if I had chosen a multiphysics template, you would see additional options there, which I'll show you in a little bit. But let's say I want to assign a force. So that's where I'm assuming that the contact region or the force distribution or the load path is going to be, right? So just apply the force, and again, like all these little icons, very intuitive. Double-clicking on them kind of gives you a little box here telling, what type of, how do you want to apply the force, right? In what direction? So I want to go with using my global, using my coordinate system here. I want to say, and the different unit systems are supported, as you can see here, right? So let's say I want to assign about 9,500 pounds. So like that, I've assigned a load there. I've assigned, so if I look at my boundary conditions, that's what I have, right? So you can see how it lists clearly here that I have a support, I have a boundary condition, I have the mesh. So now if I go look at my physics task, all I really need to do is solve the physics, right? I can simply solve the physics. And that tells me that, we can go with the results, and I can update my result. And when I go to the results, you got predefined, results, equivalent stress, displacement magnitude. That's what you would really look for in a straightforward static analysis, right? So, so let's say I go to my results here. There's my stress plot. There's my deflection plot. Again, when I go to my stress plot, it gives me the maximum values there. I can go and animate it if required. Right, that kind of tells me, okay, that's going to be, that's an exaggerated animation. The true deflection is showing up in the deflection plot. So all I did was, really the Ansys AIM. I could be really a rookie in the CAE world, and I'm still able to run the analysis, define it, since it walks me through pretty much right there, right? I can always go back and look at the mesh. I can go back to the physics. Maybe I could see what material could be assigned. It by default it picks up steel, but I can always go and add a different material I want, right? I can type in there and it picks it up from the library. You can also create your own material library, look at the material properties, etc. right here, right? See that? You can have temperature dependent material properties, all that you would come to see in any SEA tool, right? So what I showed so far is a very simple, straightforward static analysis. But what about the what if scenarios? Let's say I do want to change the fillet radius, or maybe the whole location, or I do want to improve this design, right? Maybe I want to have a better factor of safety with respect to my stress. So I would like to change the geometry. So I do have edit geometry option here. So when I edit geometry, you see that how within the same environment, Ansys allows you to do typical editing that you come to see in most CAD tools, right? So where I'm able to do, for example, I can move, I can change, I can move, push and pull, right? Edit the radius, things like that. So for example, in here, let's say I want to go and select a few surfaces in here, right? I probably want to I'm just doing a geometry-based editing here, right? I'm just selecting the geometry from the original model that we analyzed, and I'm able to do pull, move, and if you were to run a fluid simulation, you can even automatically create the fluid volume, which is could be tedious in some CAD systems, and this has a very quick and easy built-in way to do that. So let's say I want to move, and I'm able to essentially move, and you could see as I move, you see some dimensions that's coming up there, right? And I do see a little t. Now, this is very important where I can use this dimension as a parameter wherein I can make a change in Ansys AIM. I'm able to use it to run like optimization studies, or I should say design exploration studies, wherein you are able to use this dimension and create a table with different checkpoints for different values and then see the output of deflection or stress, right? So that's very helpful. And I can expose that, I can change it, and the good thing is as soon as you are, as soon as you're done changing it, or as soon as you expose it, and you simply complete editing the geometry, you're back in here. I don't know if you noticed, automatically it updated the geometry in AIM, and thereby letting you know that at the bottom, which makes sense, that the geometry is updated, however, the mesh physics and the results are not yet updated. So all you really do is you have to still go through the same workflows, tasks one by one. You don't have to, right? You can essentially update the results. And when you update the results, what the software is doing right now is it's creating the mesh, it's solving the physics, and then updating the results. You can see the results. So really, you can see that, I'm really excited about this product. The reason is it's really bringing the analysis capabilities, the powerful analysis capabilities of Ansys that we all know, but to the engineer, to the designer, right, wherein he just uses this process template, right? I could always go to that. So if you remember, I mean, if I go to my geometry, right, I could go back to the geometry, change, I could go back and add that as a parameter if I want to, rerun it with different checkpoints. We have a checkpoint dashboard, which I'll show you with another example, but that can be done with any type of multiphysics. But this is just a pretty straightforward static analysis, works on large assemblies as well as parts, right? Now, let me open up another sample here, but this time I wanted you to see how we would do a multiphysics, because that's one of the biggest strengths, in my view, of Ansys AIM, where you're able to couple these different physics, right? So, for example, if I were to go into a fluid structure interaction, right, wherein again I can import, right, and I could say that I want editing capabilities, or maybe here I don't want editing capabilities. I'm able to allow configuration, because in a fluid simulation, obviously, as you know, the fluid volume is very important, right? So whether it's air or water or any other fluid, right, depending on, as it's gas, you need to model that, right? So the fluid volume. Now in this case, I have the fluid volume, but I'll also show you that the space climb environment within AIM allows you to quickly create that fluid volume also. I'll show you another example. So right now I'm allowing configuration here, and I'm creating a simulation process. Again, I'm just going to go bring in a butterfly well example. It's an assembly. And what it's doing right now is, as you can see, unlike the previous example where we had kind of very simple, straightforward one row, this time, though, you could see how it has both. It has two rows, right, wherein it's both for the structural and the fluid. It's right now bringing in the geometry also as we speak. And the advantage here is all you have to tell is, once you do your fluid flow analysis, as to what geometry is going to, in what geometry in your model should be applied, the forces and the pressure from the fluid flow, so I can do a structural analysis or a simulation through that, right? So all these, just to give you an idea that using the template is the key, or at least that's the first step when you use Ansys AIM. You could always use a single physics, but multi-physics could also be used. And as you can see, the geometry came up, but then it's very easy to understand, I think, right? All it's telling you in here with this first row, right, is telling you that once I get the geometry, you can make some configuration, maybe substitute components, de-feature, what have you, right? And then do your mesh, then your physics. Physics becomes flow now, right, obviously, because we need to do the flow analysis first based on the inlet and the outlet parameters and the setup I'm going to give, and then get the results. But then I also want configuration of the internal part, right? I have a read sensor inside, and my goal here is to, if I change the valve angle inside, I would like to know the stresses as well as the streamline, the path lines, etc. for the fluid flow, right? What about the velocity vectors? I'm interested in both the fluid simulation as well as the structural simulation. So it's able to, you see that little icon right here, that tells me how it automatically couples, or it allows flow of information from the fluid flow analysis to your structural analysis. Okay. So now that the geometry is on, I do have some nice selection tools here. Maybe as you can see, the fluid volume is the inside volume that's already there. So I want to go and add, I want to go into my configuration here and select pretty much all components except that fluid volume inside, right? And then I'm able to quickly suppress that and configure it. So you can see how I'm just using very much Windows-based right mouse button clicks to quickly get to my fluid volume part right there. Okay, this can also be created if you had not done. In this example, I had it done. But okay, so now it's again, I just have to follow that particular the tasks in my workflow, right? So the mesh. So let me go to the mesh task, and I can again create the mesh. I can maybe slide this right here. I can create a mesh right here now, but before I create the mesh, looks like I have a problem right there, right? It doesn't allow me to create the mesh. It's telling that I need to fix the inflation, so it needs boundary layers, obviously, right? When you do a fluid volume, so I can specify inflation. Now, inflation is not required where you have the liquid goes. This is the inlet, and that's the outlet, right? So I can switch to my surface selection mode and quickly select all the geometry except the inlet and the outlet, right, where the fluid is going, the water is going to go here and then come out here. And I simply add that to my location set, and this icon is telling me, so the 3D icons are telling me that inflation is applied. That's where the inflation is assigned. And now I can go and generate the mesh. So really, you could see how it's almost like you have a live hand holding throughout your analysis process, whether you are an expert or a new user with simulation. It really, it's a guided workflow, which I really like. I think they've really done a great job with it compared to the many FEA tools wherein you have to really kind of learn the interface first, right? And then that takes a lot of time, but here I think it's pretty straightforward. Now that the mesh is done, I need to look at the physics, right? So as for the physics, remember I told you this is actually the fluid volume. What you're seeing here is the fluid volume. So it could, what type of material? So I need to assign a material for the fluid volume, right? So if I go to material, by default it takes air, but I could just type in, for example, I want water right there. And again, it has all the material properties of water, as you can see. So I've assigned, going back to my flow tab here, I've assigned materials. I also need to specify boundary condition. You see the little blue command right there. It's waiting for me, or I can go use the right mouse click. I'm a huge fan of the right mouse click. I think you guys should be focusing on your products rather than figuring out where the commands are. So that way, you have everything in the right mouse click, right? So you can see how I'm going to add an inlet. So let's say that I want to add the inlet as this face, right? And once I add that, you see it puts a little icon telling you that that's the inlet. I simply double-click on it, and it gives you very minimum requirements first off, right? If you want, you can click more and it expands, or you can use the tab here on the left, right? So many places, right, depending on your preference, right? Now, let's say I know the pressure, the inlet pressure, right? with so much Pascal, again, different unit systems supported. You can also change the different unit system globally right up here, right? You can change the unit system here as well, right? Right here. So having assigned that, right, so if you see, that's where I assign the pressure, the gauge pressure. I also want to assign, let's say, a boundary condition for the outlet. And there I'm going to assign a gauge pressure. Let me add that. There's my outlet. And I'll just assign 0 pascals, right? So if I want to look at my boundary condition right there, I click on my boundary. So you see here, it's kind of like a breadcrumbs link, kind of like what you see in Windows environment, very much like that, like a search toolbar where I click on them, it highlights my boundary conditions here, it highlights my boundary conditions here, I double click into it, I can change, etc. Right? Now I also need to assign, now this one thing, it needs to know the wall, right? That's where if you think about a fluid flow, when the fluid flows and then there's a wall, right? There's the pipe wall, you know, at the interface. If you think about it, that's where the velocity is 0, right? So depending on, you know, whether it's what type of flow, laminar flow, turbulent flow, or compressible or incompressible, there are a lot of, you know, if you know CFD, that's very important that we also assign the wall, the inlet, outlet, and for the boundary, right? So when you assign the wall, though, the good thing is AIM automatically picks it up because it knows the inlet, outlet, and it's just telling you the remaining 26 spaces are going to be the wall, and I have additional options there, right? I can specify what type of wall it's going to be, a moving wall or a stationary wall, etc. Right? So, for example, I could have a baffle in there, or maybe I could have some moving components inside. So, so my point is, again, you know, you see that how even setting up the fluid flow, it's helping you throughout. So having done this, now it looks like it's ready to solve the physics, right? So I could hit solve, but I don't want to, in the interest of time here, you know, we are still going way over time here, but I didn't want to run it, so let me just open up an existing study that I have. It's more like a project, right? When you create all this, I had to run it already, and it takes about, you know, for that mesh density, it takes about five minutes for it to solve the physics, and then we can update the results. So I'm just bringing up an existing study, and once we look at the results of the flow analyses, what we will do is then we would go to the second row in my workflow tab, where I will do the structural analysis on the internal read sensor, right? I'm interested in applying the forces and the pressure from the flow into the structural on an internal component, wherein I don't need every other component there, right? So, so what it's doing right now is it's loading the same assembly, but you can see that the flow doesn't have the lightning bolt, right? So that tells me, yes, the solution is done. Obviously, I just need to update my result, right? So now, as for the results, what type of results would you typically want in an analysis like this, right? So I can add, I know there's a predefined result here for the velocity, but what I could do, I can create my own, right? I could just add result sets. What do you want, contour, streamlined? What type of plots are you looking for? Vector plots, etc. So maybe let me look at the streamline, wherein I want to select that phase. I need to tell that's where the water is coming in, right? And I'm going to have it evaluate the results. And let me just switch to a translucent mode so you can see it better. And I can also animate that fluid flow. So let me just rotate this a little bit so you could see how, the separation as to, it depends on the angle of the valve, obviously, right? So that's something that could be a good candidate for a checkpoint, right? I might want to have this angle at 45 degrees, 30 degrees, 60 degrees, and see how is it affecting my flow characteristics, right? So that's something, and I'm also interested in any other internal components that might have from a structural standpoint, right? So, other than, that's not the only thing, you can add, even calculated, you can even add your own results, like a calculated value, for example. In this case, I might be interested, for example, out here at this phase. I want to know the mass flow rate. And I'm just going to evaluate that. And you see it gives you the mass flow rate there. So you can have quantitative results like these, as well as the fringe plots, streamlines, contour plots, etc. Right? So that's the full results capabilities there. And so if I look at my results, right, I have the velocity, I have the streamline, and the calculated value for that at the outlet, right? Now, what about the structural side? I do want to take this to the structural side. So what I can do is I can activate the configuration for the structural side. So let's say it's the same assembly as before, right, that I had. However, what are the components that will be affected by the internal flow would be the internal components. So for now, what I'm going to do is, let's say I select, so quick selection techniques, right? And I want to just subtract again, so the outside components here. And once I configure that or complete the configuration step, you see what I have is a read sensor inside, right? Now, this is the one that's going to be subjected to pressure, forces, and I want AIM to help me apply the results, really map those onto this component and do a structural analysis, right? So how am I going to do that? Again, I could go to the mesh, I can run the mesh, or when I run the physics, it should automatically run the mesh. As for the physics, when I go to the structural side, I need to fix, but before I fix, you see the material assignment, right? So I do want to have, by default, it applies structural steel, but I want to assign, let's say, polyethylene for this, right? So I can assign materials, or I can also go into my structural tab, and I could say that it needs to fix the physics coupling. So it's helping me right now, because I know that AIM can connect or map the flow results onto the structural side. However, on what geometry, where is it going to add that I get to control, right? So I'm going to say physics coupling, and it allows me to pick, right? So I can go to my spaces here, and I can essentially select the surfaces, excluding the surface, right? That's going to be where I'll be supporting it or constraining it, essentially, right? And this little icon is telling me right there, right? So that's kind of the equivalent of what you see in the workflow chart, same thing, right? So that tells me that the physics is coupled, or results from the flow required for structural are coupled, right? And now I'm able to go, just do a quick support here. I'm able to say, let's add a support on the surface. And now you see the structural task allows me to solve the physics. And this should be, I'm going to run it live here because it's not a very large model, so it should be able to run it pretty quick here. It's doing the mesh, even though I didn't do the mesh, it's doing that first, and then it's solving for the stress and the deflection. And I go to my results, and you always have solution monitors, and if you look at, for example, for the flow, right? Go to solution monitors, all your, that's very important, right? Other than the cool color plots. I always say in any FEA tool, right, the convergence, that's the key, right? You're going to make some huge engineering decisions based on the results you get. So the accuracy is very important too, right? So you can monitor that as well, right? So this workflow tab is telling me that on the structural side it ran. Now I'm going to go to just update my results. So I've not really done any kind of pre-setup in this assembly, right? All AIM is walking me through that. That's the key, right? And if I go to my results here, there's my equivalent stress. There's my deflection. So if I go to my equivalent stress plot, I'm able to go animate that, right? And obviously I have options to control the appearance and things like that when you create your reports and whatnot, right? So I want to have a smoother plot right there, right? And then maybe animate it. So that's a lot smoother, right? So the idea, whatever I've shown you so far, just an example, a pretty straightforward example on a single physics, and this is a multiphysics example there. But I could go to my geometry, and if you look at the geometry, the source, this was a space plane design, as you can see, and I had exposed, remember I had shown you a little P, kind of like an icon that allows me to parameterize it. So this is something that we had exposed, a 60-degree angle. So I'm going to tell AIM to use it in my design study, if you will, right? So that would be like a design point. That's an input. Now, what are the outputs I'm interested in? I can go to my results here, and there was this mass flow rate that I had calculated, right, for the fluid flow. So that's something I would like to keep. So all I'm doing is simply clicking on the parameterize icon right there. So I'm adding outputs and inputs from my AIM analyses into my design point dashboard. That's really what I'm doing here. Now, the good thing is it's not limited only to flow, right? I can go to my structural results, and I might be interested in the maximum deflection. Now, is the end of this read sensor, is it going to go, and how much should it be deflecting? There might be limits on it, and so even on the stress, obviously, right? It shouldn't go beyond yield, right? So you can go. I'm able to go into results, and what I'm able to do is in the results, if I go into my displacement magnitude, I'm able to go to my maximum displacement magnitude here and say parameterize that. So what did I, just by clicking on those little P icons and those three values, what I accomplish is I'm able to go into my design points here, and you can see how this Ansys AIM has automatically put in a table where I'm able to go and let's say I want to add, I want to just say for 30-degree angle, how is it going to look like, right? For 0-degree angle, right? That's going to have very less separation, obviously, right? If that valve is at 0 angle, maybe minus 30, minus 60, and then just if I click on this button, it's essentially going to update all the results, including these values. So like I mentioned earlier in my presentation, the design optimization, exploration, running what-if scenarios, that's huge, I think, when you run or use any FEA tool, and AIM has that built into its workflow template there, okay? Now, one thing is those who are currently using Creo parametric. Let me just exit out of this tool. I did mention that you have a direct interface between Creo and AIM, right? Ansys AIM. Let me open up a model that I have. Very simple, straightforward part, as you can see here, right? Very simple bracket, and let's say and this is a CAD model. I have it could be any CAD system, by the way, right? The CAD system I have is obviously Creo parametric, and the goal here is, let's say I really want to quickly analyze the effect of a load somewhere. Let's say it's used in shelving system. I have some kind of a rack in here, about 20-pound load acting right in there, and my main interest is to obviously check the stresses in the fillet area. Could we improve this design? Could that bracket be something like this, right? It's a mass production scenario, right? So I'm really interested. I don't want to over-design it. Weight is important to me, right? So So for in such scenarios, I may have used several dimensions in Creo, right? My regular dimensions, your design intent that you might have built a part with, right? So you have a thickness for it, you have a radius for the fillets. I'm even able to expose these in AIM. So all I'm going to do is I can go to Ansys AIM and simply start AIM and launch AIM, right? That's one way. But since I already have AIM, I can go and do a structural analysis connected to the active CAD system, right? That's all I'm going to do. And it's not an assembly, so I don't need contact. But anyways, all I'm going to do is I'm going to create a simulation process. And you see, just like before, it has created the template, the workflow tasks for me. However, the import, I'm going to go to the import, and you see the sources. So when I go to the sources here, this is where I'm able to select the active CAD. You see here, I could go and select the active CAD part. So you, in your Creo session, so really AIM and Creo Parametric is really essentially talking to each other at this point, right? So I go to bracket part. That's the version I had in session. If I have more parts, it will all show up in my session Creo, and I'm going to import that. And you can also, while it's importing, within my Creo, let's say this angle, right, this angle, the 45-degree angle is critical to me, right? That's something that I think I should use it for design optimization. You see that it's like a D0, that's a parameter name. All I have to really do is get back to Ansys here, and I have some geometry preferences where I'm able to import dimensions, right? I just type in that D0, the parameter name. That's pretty much it, and I update. So this is more like, you could have done it at any point of time, right? You could have even completed an analysis, and then you could have done it at any point of time. But you see my 45-degree angle, right? I'm able to expose that. This is what I mentioned. It's very helpful for running a lot of scenarios, in my view. Now what I can do is, now that I have the 45-degree angle, I can use it for my checkpoints, right? But I can, again, just do a mesh, run the physics, right? I can just assign materials, what have you. So in this case, I'm going to really do a quick, let's just say I want to support, maybe it's welded at the top and the bottom here. I can also use these type of hidden selections, right? You see these icons. So it's very, very easy to use in the time that I've been showing you the product so far. You can really see how it's quite very easy to pick up, really. Now I want to attach those and make sure it's fully fixed. And I can also add, for example, I might want to add a force load. So there's my force load. I can always go and say, okay, what direction I want it, right? So maybe we'll just do assuming that I did a free body diagram, or let's say I know the X and Y components in there. So all I'm doing is I gave an X and Y component. I've applied. So if I look at my boundary conditions, right? So there's my constraint, there's my load, and I can just go to the results right away. And when you do assemblies, really complex assemblies that I showed in some of the slides there, it's even able to automatically pick up interfaces. So now that you have the results, let's say I want to look at my equivalent stress, deflection magnitude. Now I'm thinking I should be using what happens if I change this design to. So I'm able to go back to the geometry and remember the way that we had brought it in, right? The geometry source. There is a 45-degree angle that we had exposed. I want to parameterize that, and also maybe I want to go to my results, and the stress and the deflection, right? Maybe displacement is what I'm interested in, because a small deflection on this part is going to create a huge deflection at the end of the part that it's attached to or bolted to, right? So that's important. So I'm going to go and specify that. So once I specify both these as parameterized sets, I'm able to go into my design dashboard, right? And wherein it allows me to pick. I mean, I can go and now, just like before, like with that other example, I could say, what if it's like 60 degree, or what it's like, I don't know, 50 degree here. So my point is, you are able to run design variations like these, and also I could simply say, I want to update all design values. So what it's really doing right now is it's Creo and Ansys AIM are essentially talking with each other at this point, where it is updating that parameter or the checkpoint, and Ansys Design Modeler is using the checkpoint to do the design exploration. So it's kind of amazing how in one single environment it allows you to run what-if scenarios. So it's now doing for the second checkpoint, as you can see, it's doing the data import, right? And the good thing is, once you're done with these type of analyses, it's doing the meshing, doing the physics, solving the physics. You can see at the bottom right corner, it's really informing you, and it's updated the study. And all right, so it even gives the results. So you can really see, like, you can see those. Let's say I select the checkpoint 1 or the design point 1, the design point 2. You can see the difference in the deflections in each case. Also, not only that, I'm able to go to a certain point. I can go to the design point 1, go to design point 2. Right, so what you're really going to see with when I pick each design point, is you see how the angle has changed. So this gives you amazing possibilities to explore design, I think. Sorry I went already over time here, but hopefully all of you got a good overview. I'm hoping to run more of these seminars on specific topics in the AIM environment, but since this is our first webinar, I wanted to just introduce you with a few examples. So getting back to, let me see if I have any other. Let me see in the chat session if there are any questions. If you could start typing in your questions there. All right, so no, it's not multi-phase. Multi-phase is not supported yet, Brian. It supports only multiphysics. When AIM was introduced in last January, it was 16.0, and now it's 17.0. But they are, with each release, they are slowly making it more and more powerful. But it's just meant to complement their existing flagship products, not the replacement. As to how much for a license, please reach out to our TriStar account reps. They might be they'll help you with those, with the questions on how much. Okay, sort of comparing it against Workbench. If you think about it, it works on Workbench. It's technology, right? If you see the projects and everything, it's kind of like that. However, think of it as an environment wherein we have a template, but behind the scenes, it's still using Workbench technology. Yes, variable mesh is, yeah, you can control, for example, in an assembly, you are able to control specifically certain objects. You want to have a different mesh size. So yeah, I didn't show those during the demo, but yeah, don't think it's just one single slider. You are able to go to each component and specifically assign higher mesh density. No. There is no node limit, as far as I know. I need to double check that again with Ansys. I've not seen any on that, but I'll definitely have to get back to you on that if there is a specific node limit in Ansys in Ansys AIM compared to their traditional flagship products. can non-space plane geometry be modified by AIM once loaded? Yes, absolutely, right? So imagine having a stepper and IGES file and that you brought in into Ansys AIM, and you would like to create or edit some geometry. Typically, during my industry days, I've always had to, when designers give me, I used to be an analyst, and I always have to defeature components, right? I mean, there are so many cosmetic features that they add from a design standpoint, but from an analysis standpoint, that's really cosmetic to me, and I don't need them. So yeah, so to answer your question, yes, when you click, remember when you use a template to allow editing geometry. So that's one of the powerful things in 17.0, where you're not even seeing. All you're doing is from Ansys AIM, you're simply getting into an editing environment, which is essentially space plane, and then that's where you can do your editing and come back, update the analysis. Does AIM, the inflation is essentially what it's doing is it's adding boundary layers. For the fluid flow, if you think about how many boundary layers do you need to add, and that will really drive the accuracy. You can even control the number of layers. That's going to drive the accuracy of your final fluid flow solution. And it's very common to use that in most CFD tools. Imagine like in the structural side, when you do a mesh refinement, it's kind of like the equivalent that you do on the fluid side. So again, I think I already answered that question. Does AIM works with Workbench together? I mean, so behind the scenes, it is the Workbench technology. It's just that it's a new environment. So again, like I keep repeating, the traditional Ansys flagship products were more geared towards the analyst, for the high-end analyst. And as you can see, this one, AIM, complements that. So in a company, typically you have designers, engineers, analysts. When you have those different segregations, they have their own job to do, or they work on the model and then they pass on the design to an analyst. I'd say with AIM, we are trying to democratize, or at least Ansys is trying to democratize AIM analyses to the design engineering group. So now there might be a fear in analysts and method leaders saying that, is that going to be, how could designers do analysis? The good thing is you're able to control that, right? AIM allows you to create your own templates, customized templates with scripting. It works on, I believe, the Python scripting, and you're able to really deploy, to your different departments or design groups, templates and best practices, so that's going to be one of the biggest advantage in my view of AIM, where it's really geared towards the design engineer or the mechanical engineer or the product design engineer, and you don't have to be the traditional SEA guru. Is my point, and those flagship products are still there. It still has its power and capability. However, AIM is for the designers. Like I showed you, it's so intuitive and easy to use. Non-linear materials are not yet supported in AIM. Linear materials are supported as of 17.0. Okay, there's a question. Could you please detail what is possible in comparison with Creo simulator fatigue analysis for non-linear materials? Now, if I were to compare, since I've used both, Creo Simulate is primarily meant for structural and thermal simulation only, and it has its limitations. Ansys AIM, on the other hand, is more for, you can see that it has multi-physics capabilities and predefined workflows and templates that has the same depth and the power of Ansys for the most part, but it's so easy to use. So it's more, so it's like, I have to say there are two different products, and it's more for multi-physics and for fluid structure interaction and structure thermal interaction. And I didn't show you an example of electric conduction, but you can also have that. That's the real difference between the two. Is a Creo interface with AIM and extra modular? Does it come with the software? That's a great question. I know there are, Ansys has the reader licenses for like a ProE reader license or a SolidWorks reader license, in order to read directly. I'm assuming that is still the case with AIM, where you need to have that CAD interface. You can, when you install it, all you typically do is configure it, right? You have to point it to the location where Creo was installed, right? You just have to specify the Creo installation folder, and that's how you saw how my Creo Parametric 3.0 and Ansys AIM 17.0 were talking to each other, right? So, but then I will have to get back to you on that, Brian. If it's still an extra module, I'm not positive on that, but I'll definitely get back to you as a follow-up. How to enable AIM in Creo? Okay, so when you install AIM, you might have got an option for, I can probably send you documentation on that, Jerry, but just to give you a quickly to tell you how it works is, you could just run, when you install AIM, you might have gotten options for CAD configurations where you could select like Autodesk, SolidWorks, Solid Edge, Creo, and most of the CAD systems out there, right? All I had to do is where it'll walk you through this pretty easy, where it asks me to point to the bin folder. When you install Creo, as you all know, you have that common files, parametric, bin. You just had to point to that, and it was all set. But I can maybe send you with some screenshots as a follow-up. I'll send it to you, Jerry. Any magnetic modules in AIM like Maxwell? Great question. I had the same question to Ansys, and with 17.0, it is in the beta right now. So maybe in 17.x, I don't know if it's going to be 17.1 or .2. I can get back on that as to when exactly it will be fully functional. But right now, with 17.0. Magnetics is being introduced in AIM, but it's obviously beta. That means it's not yet ready for production, something to play around with, right? So just an FYI on that, John. All right, so looks like we have gone through most of the questions there. And I hope all of you got a good overview. I know we went beyond time, so hoping to complete it in 30 minutes. Obviously, it took well over that, but I hope it was worth the time for you guys. And thank you very much for all of your time. For the time you guys spent today with me in this presentation. We are TriStar as a company. We are excited about this AIM product. So we are able to give additional value to our customers on the simulation side. So if you have any questions, please let me know. There's my email. Please let us know. Also, in our website, if you want to give us some suggestions for future webinar topics. As you know, we run webinars. Our engineering team runs webinars on Creo and Visual PDM Link and Ansys and pretty much all the other products, all the products that we resell. We would like to hear from you if you have any specific topics on these that will help us in your feedback to come up with new webinar topics. So until we see you in the next webinar next Thursday, all of you have a great rest of the day and a great weekend. And thank you very much.